Okay. So we're covering two sections today. 11.4 talks about exact circumference and partial circumference. So first of all, here's your two formulas that are on your formula sheet from the SOL. The exact circumference means you're leaving the pi symbol in there. When you're asked to find an exact circumference with a diameter of 18 inches, here's our formula, pi times the diameter. Well, if the diameter is 18, our exact circumference is 18 pi inches. You leave that in there because that accounts for all of those decimals that are unending that we can't account for. We don't even know the ending of. So this is my exact answer because that symbol stands for all of those numbers. Moving on, here's a new formula for today to find the arc length. Remember, in the past we talked about the measurement of an arc being in degrees. This means the length, like 10 centimeters or 5 inches or something like that. This is what we're talking about today. So to find that exact length of a partial circumference, this is the formula you'll use. Arc length, which is the distance. We take the central angle times 2 times pi times the radius divided by 360. I want you to notice that that is the circumference formula. So you're taking the circumference, multiplying by the central angle and dividing by 360 to find the length of that arc. So this example, 60 is my central angle, times 2 times pi times the radius is 17, divide by 360. When you plug all of this into Desmos, you get 17.8 centimeters, and this is a rounded answer. Next one, very similar kind of problem. My central angle is 100 times 2 times pi times the radius, divide by 360. Again, plug that into Desmos. My rounded answer is 34.9 feet, which is the length of this arc, the black part of that circle. So it's part of the entire circumference. The next example, we're given the radius, we're given the arc length. We're working backwards using that formula. So this is what I started with. The arc length is 8.73. We're multiplying by the central angle, central angle times 2 times pi times the radius divided by 360. As long as we know 2 out of those 3 unknowns, we can use this formula to work backwards. I plugged in the arc length and I plugged in the radius. We're going to work backwards to find that central angle. The first thing I did was multiply both sides by 360. That's where this number came from. 8.73 times 360 gives me this. And I need to divide by 20 pi on both sides to get that x by itself, which gives me that central angle of 50. So in this section, I want you to be able to know exact circumference and finding a partial circumference, which is an arc length. So 11.5. Area of a circle, this is the formula from your formula sheet. To find an exact area, you would just plug in the radius and square it. Just like I said before, you're leaving that pi symbol in there. So in this case, be careful, this is a diameter given of 24, which means the radius is 12. When we plug that in, our exact area is 144 pi centimeters squared. There's no rounding there. For this section, to find a sector area, a sector is like part of an entire circle. Looks like a piece of pizza. And to find that partial area, we're going to do very similar to what we did with the partial circumference. Central angle times the entire area divided by 360. So over here, we would take that central angle of 130 multiplied by pi times 27 squared, divide by 360. For this one, we don't have this arc, but we can subtract from 360. 360 minus 209 gives me 151. So that central angle is 151 times pi times the radius squared, divide by 360, and that would give you that partial area of that shaded area. So again, partial area, very similar to partial circumference. I also want you to be able to find the exact area of a circle.